Let's go to page 559 and start with number 1. Okay, so this one you need to find the value of the sixth trigonometric function. Okay, so here's theta, and this is 6, this is 8. So from your geometry, the spatial triangle, it would be 6, 8, 10. Now, if you don't get that, then you need to use Pythagorean theorem. So you got a squared plus b squared equal to c squared. So you're going to get 6 squared plus a squared are equal to c squared. So 36 plus 64 equal to c squared. So 100 equal to c squared. So c equal to 10. Okay, but this is the second harmonic of the 3, 4, 5 triangle. Okay, so once you get all three sides, then you can write your functions. So sine theta is this over this, so equal to 8 over 10, so equal to 4 over 5. Okay. And cosine is this over this, would be 6 over 10, so it's adjacent over hypotenuse, would be 3 over 5. And tangent theta is the opposite of adjacent, so it's 8 over 6, and so equal to 4 over 3. Once you find the 3, then you can find the other 3. So sine go with cosecant. So cosecant would be just the reciprocals would be 5 over 4, and secant would be 5 over 3, and cotangent would be 3 over 4. Okay, so those are your answers. Okay, let's go to number 3. Okay, so this is your 45-45 spatial triangle. Okay. So 2, 2, this would be 2 square root of 2. Okay, so from this case, you got sine of theta equal to opposite over hypotenuse, would be 2 over 2 square root of 2. The 2 will cancel out, and you have to simplify this. You have to multiply by square root of 2 over square root of 2. So this is equal to square root of 2 over 2. Okay, cosine theta is equal to, since are the same, so cosine of theta will be equal to that. So it would be same. Okay, so it would be equal to square root of 2 over 2. Okay, tangent theta equal to opposite of adjacent, so equal to 1. Okay. Now after that, you go ahead and do the cosecant. Okay. Now when you're doing the flipping, don't flip this one, because once you flip this one over, you have to simplify. Okay. So just go and just do this one. So this is square root of 2. This is 1 over square root of 2. So when you flip it over, this one will give you square root of 2. Okay, so same thing. Secant of theta will equal to square root of 2. And cotangent, okay, would be just equal to 1. Okay. Another way to do it is that sine is opposite over hypotenuse. And cosecant would be just the reciprocal, so it will be hypotenuse over opposite. So this over this, the 2 will cancel out. So that's how I get that. Okay, let's go to next one. Okay, number 5, find the value of the sixth trigonometric ratio in the standard form. So the point is at 8, 15. Again, if you draw that, so 8. So if 8 is about, this is about twice as long, so 8 is this long, then you make it about twice as long. Okay, so this is 8, 15, and it's your theta. Okay. Now, from your geometry, this is a spatial triangle also, so it would be 8, 15, 17, triple. Okay, so this is a spatial triple, 8, 15, 17. Again, if you don't know that, if you don't remember that, you just use the Pythagorean theorem. Okay, so a squared plus b squared equal to c squared. So 8 squared plus 15 squared equal to c squared. So 64 plus 225 equal to c squared. So 289 equal to c squared. So c equal to 17. Okay, so you can do it either way. Once you get all three sides, then you can write your functions. Evaluate your functions. So sine theta will be equal to opposite over hypotenuse. So it would be 15 over 17. Cosine theta is adjacent over hypotenuse, so it would be 8 over 17. And tangent theta equal to opposite over adjacent, so it would be 15 over 8. So once you get the three primary function, you can get your secondary. So cosecant would be just 17 over 15. And secant would be 17 over 8. And cotangent would be equal to 8 over 15. Okay, let's go to number 7. The point is 3, 1. So 3, and the 1 is 1/3 of that. So, make this into about this much, right? So again, this is 1, and this is 3. Okay, this one is not a special triangle, so just use your Pythagorean theorem. So a squared plus b squared equal to c squared. So 3 squared plus 1 squared equal to c squared. So 9 plus 1 equal to c squared. So 10 equal to c squared. So c equal to square root of 10. So put square root of 10 over here. Okay, once you got three sides, again you can do your ratio. So sine theta equal to opposite over hypotenuse will be 1 over square root of 10. And you have to simplify, so multiply by square root of 10 over square root of 10. Right, so equal to square root of 10 over 10. Cosine theta equal to adjacent over hypotenuse. Okay, again multiply by square root of 10 square root of 10, so equal to 3 square root of 10 over 10. Okay. And tangent theta equal to opposite over adjacent, so equal to 1 over 3. Okay. So once you do that, you can go and do the secondary function. So sine go along with the cosecant. So cosecant of theta. Now what you want to do is, you don't want to flip this one over. If you flip this one over, you have to do the simplifying anyway. So flip this one over, right? This is your original, right? Original is opposite of hypotenuse. So when you flip this over, it will be square root of 10 over 1. Okay? And this one, again, don't flip this one over because this is your original, right? This is your original. So flip this one over, then you get square root of 10 over 3. Okay, so you can flip this over. If you flip this one over, you have to do more simplifying. Okay? Okay, cotangent would be just equal to 3. Okay. Okay, let's go to next one. Okay, this one has a table. Okay, so you have sine theta, cosine theta, tangent theta, and this is number 9, number 10, number 11, number 12, number 13, number 14, and number 15. Okay. And let's go and write down what it's giving. So this is 3 over 5. This is 1/2 square root of 3 over 2. And this is square root of 2 over 3. And square root of 161 over 15. And this is 5 over 13. And this is 1 over 4. Okay, so for each one of these, you have to go and use information to draw your triangle. So for number 9, your triangle is 3 over 5. Okay, so this is 3 over 5, right? 3 over 5. That's opposite over the hypotenuse. So you can use your Pythagorean theorem, or you use a spatial triangle. So this is a 3, 4, 5 triangle. Okay, again, so you can do that. If you don't see that, if you don't know your spatial triangle, then you have to do this. You have to go a squared plus b squared equal to c squared. So a squared you don't know plus 3 squared equal to 5 squared. So a squared plus 9 equal to 25. So a squared equal to 16. So a equal to 4. And we don't worry about negative because the length cannot be negative, right? So that's how we get that. Okay. Okay. So cosine is adjacent over hypotenuse would be equal to 4 over 5. Tangent is opposite over adjacent would be 3 over 4. Okay. Okay, let's go to number 10. Okay, I know we're doing arts, but let's go and fill out the table. So cosine is 1 over 2. So cosine is this over this. The triangle is kind of bad, so I'm going to redraw the triangle, right? Because this, so notice this is half of that, so this would be square root of 3. So the triangle is actually more like this: 1 square root of 3, 2. Okay, so this would be 60 degrees and 30 degrees. Okay. So sometimes you kind of have to just draw the triangle, and you might have to adjust and redraw the triangle. Okay. 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 So in this case, so sine would be opposite over. So sine would be opposite over hypotenuse. So this would be square root of 3 over 2. Tangent would be this over this would be square root of 3. Okay. Okay, so we're going to keep the table over here. So let's go to 11. Okay, so number 11. Don't need a parentheses. Okay, number 11, you have a cosine. So cosine is horizontal. So this is square root of 3, 2. Okay, so it's for number 11. So from here, again, this is your 30-60 spatial triangle, so this will be equal to 1. Again, if you don't know that, you just have to use Pythagorean theorem, a squared plus b squared equal to c squared. But you need to know your spatial triangle, okay? So you're going to get square root of 3 squared plus b squared equal to 2 squared, right? So you don't know that one, right? So you're going to get 3 plus b squared equal to 4. So b squared equal to 1, so b equal to 1. But you should know your spatial triangle, okay? Okay, so from here, sine is opposite over hypotenuse, so it will be 1 over 2. Tangent is opposite over adjacent, so 1 over square root of 3, and you simplify that, you're going to get square root of 3 over 3. Okay, so again, tangent theta equal to 1 over square root of 3, and then you times by square root of 3, square root of 3, so equal to square root of 3 over 3. Okay. Okay. Let's go to number 12. Okay, so sine is opposite over hypotenuse, so square root of 2 over 3. Okay, so again, use your Pythagorean theorem. So a squared plus b squared equal to c squared. So a you don't know, b, again you substitute square root of 2, c is equal to 3. So a squared plus 2 equal to 9. Okay, so a squared equal to 7, so a equal to square root of 7. So this is square root of 7. Okay, so when you do that, you can figure your cosine. Cosine is this over this, so it'd be square root of 7 over 3. Now tangent theta equal to opposite of adjacent, so it'd be square root of 2 over square root of 7. You times it by square root of 7 over square root of 7. So you're going to get square root of 14 over 7. Okay. Okay, let's go to the next one. Okay, number 13. So sine is a vertical. So it'll be square root of 161. So it's vertical over it's opposite over hypotenuse. Okay? So from this, that's your picture. So you can use your Pythagorean theorem. A squared plus b squared equal to c squared. So a squared you don't know. B would be square root of 161. C would be 15. Okay? So you got a squared plus 161 equal to 225. So a squared equal to equal to 64. So a equal to 8. Okay? Okay, so once you do that, you can figure out your cosine. So cosine is adjacent over hypotenuse, so it would be 8 over 15. And then tangent is this over this, so it would be square root of 161 over 8. Okay, let's go to the next one. Okay, number 14. So cosine is the adjacent over hypotenuse, would be 5 over 13. So this will give you this. You can use your Pythagorean theorem. So this is your spatial triples, will be 5, 12, 13. If you don't know that, you can use your Pythagorean theorem. So A equal to 5. B you don't know. C is 13. So you got 25 plus B squared equal to 169. So B squared equal to 144. So B equal to 12. Okay. So once you get three sides, you can figure out the sine. Sine is opposite over hypotenuse, would be 12 over 13, right? And tangent is opposite over adjacent, so would be 12 over 5. Okay. Okay, let's go to the next one. Okay, number 15. Okay, 15, you got 1 over 4, and that's a cosine. So cosine is adjacent over hypotenuse. So 1 over 4 will give you 1 over 4. Okay, so use your Pythagorean theorem. A squared plus B squared equal to C squared. So A equal to 1. When you use Pythagorean theorem, it doesn't matter which is A, which is B. A and B can be switched. Okay, plus B squared equal to 4 squared. So 1 plus B squared equal to 16. So B squared equal to 15. So B equal to square root of 15. So this gets square root of 15. So once you do that, you can figure your sine. Sine theta is opposite over hypotenuse. So it will be square root of 15 over 4. And tangent is opposite over adjacent. So it will be this over this. So it will be just square root of 15. Okay. Okay, let's go to number 17. Okay, you got cosine of phi equal to sine of 40 degrees. Okay, so you have to use the cofunction identities. Okay, and so that identity, okay, you got to go back and look at the identity that you learned from before. Okay. So this is from page 557, and this is your cofunctions, the co-identities. Okay, so remember this. They have to be complementary angles. Okay, so therefore the phi have to equal to 50 degrees. Okay. So cosine of 50 equal to sine of 40. Okay, and that's it. Okay, number 19. You got secant of phi equal to cosecant of 80 degrees. So again, they have to be complementary angle. So phi equal to 10 degrees. Okay, so just a little bit reminder on your cofunctions. Okay. Let's go to the next one. Okay, number 21. Okay, you have this triangle over here. You can draw a big triangle so you can label them. So this is A, B, C, and it's a right triangle. So small a is facing the big A, small b will facing the big B, and this is small c. Okay, for number 21, it tells you that B is equal to 2, angle A equal to 45 degrees. Okay, and from the length of the sides and the measure of the angle, they are not given. Okay, so basically you will need to figure out everything. So anything is not given, you have to figure out. So the way to do this is just go and do your ABC. So A, B, C. Those are angles and small 1. So basically you want to do everything. Okay? Okay, so B is giving, so it's 2. A is 45 degrees. C is 90 degrees. Then what you do is use your the 3 angles have to equal to 180, right? So if this is, and this has to be complementary angle. So if this is 45, this has to be a 45 degrees. Okay? Okay, so now you have to, so since this is 45 and this is 45, so this is 45, 45 spatial triangle, so this has to be the equal. So B equal to 2, so A will equal to 2. Okay? And the hypotenuse, so 45, 45 spatial triangle, the hypotenuse would be square root of 2 times by that. So this will equal to 2 square root of 2. Okay, and that's it. Okay? So again, that's everything. Okay, let's go to 23. So you can draw a triangle. So A, B, C. You got small a, small b, small c. Again, just go and get all your information together. Okay, so what we got? 23, you got small c equal to 20, and angle A equal to 60 degrees. Okay, so the picture is kind of off, but okay, you know what? Let's go ahead and redraw it. Okay, let's go and draw it the correct way. So A is 60 degrees. So this is A, B, C, and so this would be A, oh, yeah, oh, back up. This is B. The C is always the right angle, okay? And so this would be small b. Okay. And so what we got? So small c equal to 20. Okay, so 20 and A equal to 60 degrees. Again, angle C is 90 degrees. A and B have to be complementary angles, so this have to be 30 degrees. So this is your 30-60 spatial triangle. Okay, so this came from cutting the equilateral triangle in half. Okay, so notice that it cut in half. So this is half of that because this so if this is 20, this would be 20, this would be 20, right? So this has to be a 10 and 10, right? So this has to be half of that. So B will equal to 10, right? This is half of that because this is half of the equilateral triangle. And to get A, the long leg is a square root of 3 times that. So A would be 10 square root of 3. So make sure you know your triangle. Make sure you know your 45-45 spatial triangle. Know your 30-60 spatial triangle. Okay, let's go to next one. Okay, so you can get your everything, write it down. So that way, when you write it down, that way you make sure you're not missing anything. Okay, that way it's very clear that you got everything. Okay, so number 25, you got A equal to 4, B equal to 4. So this is equal to 4, this is equal to 4. So right away, since these two legs are congruent, they are equal, so that means this is a 45-45 spatial triangle. Right? And C is always equal to 90, so this would be 45 degrees. 45 degrees, right? So that's very easy. Now for 45, 90 spatial triangle, the hypotenuse is a square root of 2 times that. Or you can just use Pythagorean theorem, A squared plus B squared equal to C squared. But you should know your spatial triangle. So this would be 4 square root of 2.